Hi folks, this is Roger from Kanka Labs, and today I'm going to demonstrate to you our microcontroller development system Modul-Lino. Now I know you will immediately say, no, not another Arduino clone, but you'll see in a minute that it's not another classical Arduino clone. First, a little bit to the history. We, for many years, have used this development system, which we originally called ESM32, which stands for the German abbreviation of development system for the ATMegas 32. And we discovered by chance that we could make it Arduino compatible with a very simple hardware modification, and now it is really versatile and has many features that you can't get on the classical Arduino Uno. And so let's directly jump into the demonstration of the features, and in further parts of this video series I'll show you a few demonstrations what you can do with it. So let's take a look at it in detail. So before we go into some detail, let's take a quick look around what's on board. Most conspicuous is of course the 16:2 LCD backlighted. It is on a standard 16-pin header, and you even can exchange it with other LCDs. I'll show you later that if we connect a 4-line by 20 character LCDs, it immediately works. We have an external power jack, standard jack, where you can supply the board with anywhere between 9 volts and 24 volts input voltage. That might be useful if either USB's power is not available, or if you want to build some additional circuitry here on the breadboard area, which needs more than 5 volts, then it's quite handy to have some higher external voltage available. We have an LED to show that power is available. We have a standard DB9 connector for serial communication, and you can switch the serial communication with these two little jumpers if it shall go over the DB9 port, or behind the USB jack there's hidden below the LCD, which we'll in a minute take off to show what's below. There's a FTDI FT232R USB to serial converter. Serial communication can be either over standard DB9 connection if you have a serial port available, or over USB. And with this red marked jumper, you can set where the power comes from for the board, either from the external power, or if I would change it now where USB is not connected, if I set it to USB, of course the board will not power up because there is no power. Don't wonder when you see the message that this is ESM32. This is the motherboard, which is identical in our development system with an ATMegas 32 and with the new Modul-Lino, which uses an ATMegas 1284. The message is just the same. So this is a specialty here with these jumpers. You can use the ISP programming mode, which is also on a standard 6-pin header here. You can program the ATMegas including bootloader and fuses and EEPROM over the USB. You don't need a pre-programmed ATMega. You can buy a blank ATMega, insert it, and you can program over USB all fuses. You can program in a bootloader, which I'll show in a later part of the video. And if you use this programming mode, then all the jumpers have to be set. If you don't need it anymore, then you disconnect them so that the port pins are freely available again. Well, we have a reset switch, and we have pin headers for all 4 8-bit ports. Now I've already, as you have seen, I've touched one, and one of the programs is now, of the test programs is now running. We have here a jumper to disconnect the analog reference voltage. When it is set, the analog reference voltage is set to the 5 volt analog voltage power supply. When you disconnect it, you can set the analog reference voltage to any other voltage you want it to. And here we have some a trim pot connected to the ADC 0 input pin. You also can disconnect it if you want to use this pin not for the trim pot but for other purposes. You have 4 push buttons and 2 LEDs, and you can disconnect the connections to the push buttons and to the LEDs with these 6 jumpers. And well, here we have the main quartz crystal. As I just told you, this is just for demonstration the development board with the ATmega 32, which uses an 11 point something megahertz quartz crystal. The reason is because with this frequency you can easily divide it down to the standard baud rates for the serial communication. But of course, in a minute I'll show you the identical board with the ATmega 1284, where we of course supply the 16 megahertz quartz, but the quartz is interchangeable. I'll disconnect, and you can see it has its own quartz connection here. You can just pull it out and put any other quartz, which is small enough, of course. And so you are not bound to use the quartz that is standardly used in Arduino or Arduino-compatible devices, which is usually 16 megahertz. For example, sometimes you want to reach the highest or work with the highest frequency available, which is 20 megahertz here, and then you just take a 20 megahertz quartz. Okay, the 4 8-bit ports are repeated here. You can, if you want to, also still use some headers here. Basically it's thought to be available here for direct connection to the breadboard area. For that purpose we also have here 4 ground connections and 4 5-volt connections. And if you either don't need to this breadboard area, or you have finished your development, you can break it off. You can see it's serrated here, and you simply can break it off. So that was a first look at what's on board. Still some detail is here. That's a 500 milliamps polyfuse. That is to protect the external USB connection, so that if there's more current drawn here than the max allowed 500 milliamps, then the polyfuse will disconnect the board from the external USB supply. So that was it for the first look, and now let's take a look what's under the LCD, and I'll show you how to use other LCDs with the standard 16-pin header. So as you might have noticed if you looked closely, when we developed many years ago the ESM32 Universal Development Board, we choose an LCD which has the backlight connections on the right side, on the beginning, on pin 1 and 2 of the header. Most LCDs you get these days have exactly the reverse order, which means they have the backlight connections on pin 15 and 16. So that's why in many LCDs you want to use with this board, the backlight function will not work, or you have to wire it for yourself. That was, of course, in hindsight, an unfortunate choice we made at that time. In the future version we will, of course, put the pins for the LCD backlight on their standard orientation here on pin 15 and 16. By the way, if you have any suggestions for a future version of the Modul-Lino, what you would like to have still on board, like more trim ports, then please visit our forum and tell us about your ideas or your wishes, because we surely will make a version 2 of the board. So, and one thing we definitely will change is the position of the header. Now let's take a bigger LCD and see if this works too. We'll disconnect the power. The LCD is usually secured with 2 or 4 screws from down below, but of course I took them off before. Here you see a little mod we had to make. This is also something that in future version will be not look this way. That's because we needed an external reset signal from the FTDI, which we could program from outside over USB. That was the only thing we had to change from our old development board to make it 100% Arduino compatible, and we had no choice but to hand solder a little 100 nanofarad SMD capacitor directly to the reset line of the processor. But well, it doesn't look nice, but it works. So one last thing about the possibilities you have with using the FTDI chip. You have all in all 4 ways how you can program your processor. You can either use with an external programmer the ISP connection with the standard 6-pin header, or you can use the ISP over the FTDI USB to serial converter if these 4 jumpers are set. The programming mode is the same. The difference is here for this ISP connection you need an external programmer, and if we use the ISP mode over the USB to serial converter over the FTDI chip, then we can program it directly over USB without any further hardware. And as we will know, the ISP programming mode means you can use all programming modes of the processor, which means not only the hex file, the EEPROM where the software will be loaded, but you can program the fuses, you can program the EEPROM, and you can program the bootloader inside, which is missing when you buy a bare blank chip. So now let's try out a bigger LCD like this one, which is a 4-line by 20 character LCD. There's one thing we have to watch when placing it on the header. That is because of the different position of the LCD backlight LEDs, we have to place it 2 pins aside, so then the backlight will not work, but the other connections are the right way. I'll shift it a little bit so that you can see the full display. And now let's turn on power, and you can see because the software commands for the LCD are the same as for the standard 16:2 LCD. It immediately works without any software change. Of course, only the first 16 characters in the first 2 lines are used here, but it immediately works, and that way it's easy to use bigger LCDs if you have an application where you need that. So I've put on the small standard LCD back again, and for a short demo I will show you what our test program is doing. We use this test program for final testing our boards, and I'll show you later how you can program this test program for yourself into the processor. Well, you have 4 test modes depending on which push button you switch. Let's start with test number 1. It just counts up from 1 to, I don't know, 200, and gives these the displayed numbers back over the serial connection to the PC, so that the serial connection in the direction to the PC is tested at the same time. Now for changing to one of the other programs, you shortly have to reset it. And now we choose test program 2, which also transmits the data over the serial port, and this is to test the ADC, which when it's connected to the trim pot, which goes from 0 to the max of 5.000 volts, and the max ADC value, as you will know, in a 10-bit ADC is 1023. So test is also okay. Now let's choose test number 3. It tests the LEDs, and it tests the port not in PWM mode, but in a digital output mode, and you can set LED 1, LED 2, both LEDs, or all LEDs off. And the last test, test number 4, tests the PWM mode. We can watch what happens when the PWM value goes up here. Then the LED number 1 will become brighter. Of course, it's linear, so it should be logarithmic to have a greater range for the LED brightness. But anyway, it works, and with the second one we can dim it down again with smaller PWM values, and the same is for LED number 2. It gets brighter the higher the PWM value gets, and with this one we can set it low again. So that's the basic test of the external components and some functionality of the communication. And now let's take a look at what you can develop with this board. I'll show you one example now, and another still much more sophisticated example what we have developed with this board in another part of our video series about the Modul-Lino. So here's one example what we once developed with the Modul-Lino board, or with its cousin, the ESM32. As you perhaps will know, our master Burkhard Kanker is quite in love with radio in all of its forms, and one of our favorite is this little chip from Silicon Labs. It's the SI4735, which is a complete AM/FM receiver, including the shortwave bands, including RDS decoding, and it's one of the best radio chips available. And perhaps you might have noticed already that we have quite a lot of projects around this little adapter board, which you can also buy at our shop. And this one was the most sophisticated one. It was published by the Elector magazine, and I'll show it you in a version which where I modified and extended the original firmware, which is also open source and can be downloaded from our shop or from our homepage. You'll see it has 4 push buttons and 2 a volume pot and an encoder. It has a programming standard 6-pin header for ISP programming, and well, an audio amplifier where you can either put 2 loudspeakers, because it is a stereo FM receiver chip, or you can put headphones on. And here you have the antenna connections, where you can for each band, like the long wave, the mid wave or AM, the short wave and the FM reception, or a general input jack and a BNC connector. So it's quite versatile. It works all with 5 volts. I've used here 4 rechargeable batteries, and it has a USB connection because it can be controlled also over USB from the PC. And as you perhaps might notice, one of my first SMD soldering trials in hand soldering the FTDI chip, which establishes the connection from USB to serial connection of the used ATMegas. Now let's power it on and see what it does in the display. Well, the acrylic cover here is also a little mod by me. I've lasered it in Aachen at the local hackerspace. And well, now let's see what we can see in the backlight illuminated LCD when it turns on. You can see first the analog output here, where you can put an analog display to. It can be reprogrammed either to set to the level, or the stereo separation, or the signal to noise ratio. And now already the radio text is scrolling over the display. I'll turn it out again so that we can see what initially is displayed. And first of all, it displays the last received transmitter. It displays the dB microvolt value, the signal to noise ratio, and as soon as it receives radio text, it decodes the radio text and scrolls it over the display. And here the time, which is also distributed over the radio text signal, and the name of the transmitter is displayed. And these 2 little self-created symbols show ST for stereo reception and RT for radio text reception. So the whole circuit was developed on our Arduino, on our Modul-Lino board, and as you can see, there even is, as a mod of mine, originally it was an ATmega 16.8, now it's an ATmega 32.8, and the firmware is, as I told you, modified, and it's the EEPROM space in the microcontroller is totally used out, nearly up to the last byte. And well, that's something you can do with our development board, Modul-Lino, or its cousin, the ESM32. And in a later video, I'll show you a much more sophisticated project which we did here at Kanka Labs, which is not completely ready, so still open for suggestions, which we also are developing on our Modul-Lino board. So let's take a look at some features of the ATmega 1284P from the datasheet. Of course, what's most notable is that it has much more flash, 128K instead of 32K in the smaller ATmega 32.8. It is 4K of EEPROM and 16K of SRAM. That is quite useful if you want to make FFT calculations or store big bunch of data and so on. It of course has a JTAG interface for debugging, and additional to the two 8-bit counters, it also has two 16-bit timers counters. The smaller Arduino only has one 16-bit counter, and 16-bit counters are quite important because they are much more versatile than the 8-bit counters. You can also connect a real-time counter on two separate pins with a separate oscillator, where you put a watch crystal on, so that even in power down mode real time can be kept, and that's something different than a software integrated real-time clock. And it has the same 6 PWM channels as the Arduino Uno, but full 8-channel 10-bit ADCs and not only 6. It has, as usual, the 2-wire or I2C serial interface, and it has two hardware serial US ARTs. The SPI interface, the watchdog timer, that's standard with the ATMegas. The analog comparator also is standard. And well, these are the most important differences. The frequency can go up to 20 megahertz if you have a 5-volt power supply, and with lower voltages like 3.3 volts you can go up to 10 megahertz. Now let's take a look at the pinout. Most conspicuous is of course that all, as I already mentioned, all 4 8-bit ports, port A, B, C and D, are fully available, and well, the rest, and you have the 8 ADC, and you already can guess from the alternate pin functions what is connected to the other port pins. Like here, this is the external oscillator for a real-time clock, and the rest is standard: the reference voltage, ground, analog voltage, the digital voltage, reset pin, and the 2 connections for the external quartz crystal. So now we won't go into detail to every single part. Perhaps one thing that might be of interest is are some features of the ADC. The first specs are standard in all ATMegas, but what's a little bit more versatile than in the Arduino used ATmega 32.8 is that you have differential mode channels with internal amplifications of either 1 times or 10 times or even 200 times, of course at reduced speed and at reduced resolution or accuracy. You don't get the full 10-bit resolution. You get 10-bit results, but valid is for example, in the 200 times internal amplification only about 6 to 8 bits, but nevertheless an internal gain amplifier of switchable from 1 times to 10 times or even 200 times is quite useful. And you have 2 internal reference voltages of 2.56 volt or 1.1 volts. That's also quite useful. So let's take a final look at the LEC channels. The first 8 ones are the standard, non-differential and non-amplified channels, and here you can see these are the modes for differential channel. There's a lot of combinations where you can measure differential voltages with 1 times gain amplification, and there are some combinations where you can select the 10-fold or 200-fold gain multiplier to measure quite small, in the microvolts range, quite small voltages on some of the differential channels. So, and finally you can also measure at least one of the 2 internal voltage references. The 1.1 voltage reference can be read out, and that's a little trick with which you can measure the supply voltage when you compare the value you measure here with a direct measure of the supply voltage. So that shall be it for a first impression on our development system Modul-Lino. In the next part I'll show you some demonstrations of what is ongoing in our development here with the Modul-Lino projects we have in progress, and I'll show you 1 or 2 projects we have already finished some time ago which were based on these development systems. If you have any questions or suggestions, as always, you can leave them in either in the YouTube comments down below or jump over to our forum for further discussion or suggestions. And if you liked it, please give it a big thumbs up. It always helps us. So bye from Kanka Labs. Until next time.